coming to our panel discussion this morning. I'm Dave Soleil. I'm going to be moderating the panel, and we're going to be getting all the presentations here teed up and started. Originally in the program, this was billed as additive manufacturing, and we're certainly going to cover additive, but we're really going to do advanced manufacturing with additive manufacturing and other technologies leading the way, and that's really our motto for this morning. So I know, so could we get the first slide up of our panel members? And you want to do a picture quickly before we start? Would you stand up here? Okay. Thank you very much. Thank you. Okay. No, I won't need to change. Yeah. Okay, so as I was saying, we're putting this in the context, additive and other manufacturing technologies. And so some of you have been involved in additive and following this NNMI program, the National Network for Manufacturing Innovation. That was something started by the Department of Commerce, and the concept is they're creating a number of centers focused in different advanced manufacturing technologies that are designed to help the kind of leapfrog manufacturing for the United States and bring more manufacturing back to the United States. So the first of those was first called NAMI, now known as America Makes, but National Additive Manufacturing Innovation Institute. Since then, there's been what was first called LM3I, Lightweight Metals, now known as ALMI. That was another one of the centers. We had the DMDI, the Digital Design. So we have representatives here this morning who are actively involved, either working in those organizations or actively involved in them. So I would like to say, I'm assuming most people here, if you're not involved in manufacturing, you certainly have an interest. So how many people, could I just see a quick show of hands, are involved in manufacturing in here? So maybe about half. How many of you are currently, your company, currently involved in any of the NNMI centers? Buddy? Okay, about 4 or 5. Okay, good. So what we're going to do today is run through really what is happening from an advanced manufacturing standpoint. We're going to be focused again on additive as well as digital design. You can't really have one without the other. Part of the questions here will be around how are all these centers going to work together, and what's really in it for you from your perspective. So having said that, our first presenter is going to be Tim Shinbara, and Tim is with AMT. So let me, Tim is Technical Director of AMT, which is the Association for Manufacturing Technology. He researches, compiles, and disseminates current and emerging manufacturing technologies for AMT members and their partners. He also is a member of the Executive Committee of America Makes, which is the National Additive Manufacturing Innovation Institute. And he is the AMT liaison for the additive working group within AMT. Prior to AMT, he was Technology Thrust Leader for additive manufacturing at Northrop Grumman Aerospace Systems, within their manufacturing development department. Tim has a BS, a MS degrees from Purdue, and an MBA from Pepperdine. I bet that was a fun school.
Beautiful school,
Yeah.
I'll tell you that.
Okay, so Tim?
All right, thanks,
yours.
Dave. I appreciate it. At AMT, one of the things that we get asked quite often, what's trending in technology? What are the top ones? Can you boil it down and let me go tell this to our strategy team so they can go and do good things inside our company? And it's not an easy task to go after. In fact, a lot of it is a bit qualitative and not quantitative. One of the things that I do in my job is trying to put my arms around it. So we've come up with a new technology trends document. I use the word document loosely, but it's an initiative where we're going to look at the 3 areas within manufacturing that may be trending. The first one is in the needs and the requirements. So this is industry saying, I would go do X if I had Y. And then the second one is in what is trending in the manufacturing research, both basic and applied. And the third area is manufacturing activities. This would be the transition of technologies, the acceptance, the insertion of technologies on a production line in a production environment. That's a big thing to go after, and I get that. But what we've realized is whatever we do daily at AMT, and me specifically, it falls into one of those 3 categories with our research affiliates and our technology members. So some people then ask, well, who are your members? Well, our members are the folks that build, distribute, and then service or sustain the technology itself. That technology can be hardware, it can be software. So we reside in all the enablers for a production line or assembly line, otherwise the manufacturing environment. One of the things I get a chance to do is to go see what they're doing in their shops, what they have used, and to advance their state. So the trends document is a way to serve our members by saying, this is what's going on. You have limited resources, limited time, like everybody in this room, including me. And is there a way to go leverage and exploit things that are open and available, and then compile that data and provide some kind of maybe a singular infographic? In that vein, what we've done to date is kind of the blue-collar, elbow grease method. We send folks out to conferences, symposia. We participate in international production research symposia like SERP, the academy there, and ones throughout the United States in our national labs, university labs. What we found to date is they kind of fall into these 3 categories as of today. And obviously this is a living exercise. These things change, the different elements within each change. But we see additive manufacturing, obviously, as a very clear enabler for a lot of tactical reasons. But we see robotics and automation, even maybe as a bigger pie of impact, as having some of the better and more advancements to enable production in the U.S. To be globally competitive. And the third is our transformative technologies. And this is something that is coming down the pipe. It makes people think a little differently. I don't want to use the word disruptive. It just makes you transform and be creative of how you go do business the next day. So today, unfortunately, we couldn't have one of our good friends from RP+M, who is an additive manufacturing company here in the Cleveland area, on the panel with us. So what I did was add just a little bit more of some pictures and storyline behind additive in this first section. So don't get, it's not death by PowerPoint, but there's something about additive, you just kind of have to see it. And so anyway, with that in mind, additive manufacturing, the first key attribute of additive that AMT sees as an enabler is the fact of the footprint. Who now is understanding what manufacturing is all about. They're not using the word manufacturing, they're using words like make, build. Maker Faire is a great example. This is the first time in a long time, if not ever, that AMT folks have started to realize K through 12, community colleges, universities, are all starting to get their hands dirty again. Granted, with additive, it's a little less dirty than what it used to be. But the thing about it is you have to build it and break it and do all the stuff that we talked about last night with Larry and HD in the audience. There's something about getting your hands on something or on an idea and then realizing it, producing it. But along with that, there came a bit of a connotation that 3D printing, which most folks know it as, is this MakerBot world. It's this toys. But that's just not the case. No one uses the word additive manufacturing necessarily. They usually use 3D printing. But it's more than just 3D printing. It's more than just polymers. It's actually more than metals. It's also ceramics and it's composites, a bunch of different stuff. And it's not just for a toy or a prototype. It can be in healthcare-related industries, aerospace-related industries, automotive, undersea, in the air, and space. Everything, as everybody in here knows, is all a direct reflection of your requirement of your environment. So there's plenty to do in additive. But it's not ground zero with additive either. So ASTM F42, standards body in the US, and then ISO, I think it's TC62, have agreed to share some of their standards as they've been developed. Terminology is one of the first ones accepted by both groups. So they define 7 different processes within additive manufacturing. It helps you kind of put into a category what energy system you're using, what kind of material, either deposition or available means that you're going to produce your part on. All those different categories, because AM is not AM is not AM across the board. Many are more mature, some are less. So these next few charts are just a couple of the wording that ASTM has used, a little bit of pictures to go with it. So you'll see already that there's differences in the energy source and how the energy source is introduced into the media, the different types of media, and the different ways that you additively build up. In some cases, it may not be additive, and up, it's additive in all axes. And it's not just homogeneous materials with a homogeneous process. We now have subtractive and additive enclosed into one machine. Matsuura came out, I think, with one of the first ones. They didn't bring it to the US until just recently. But you also have DMG Moriseki with a machine. LaserTech, you've got, I just saw Herco filed a bunch of patents that have now been approved for that kind of hybrid machine. And it's not just your homogeneous materials. So we're starting to see carbon fiber with their resins and heterogeneous materials. Now, some powders have already been filled with glass and with carbon, but now we're starting to see the constituent material coming in even more functionalized, if you will. And people then go, well, if that's additive for 5 years from now, what can I do with additive today? And the point I made earlier was, well, there's a lot you can do. And there's still affordability cases for that, but it's not as exponentially great as people want you to believe, because there's a lot to go into the qual and the cert. And I'll stop on that, because I know we're going to talk about that probably a little bit later. But for example, back at NGC before I left, we had put 2 parts through some quals and specs. The first one is the James Webb Space Telescope composite interface. That's really on there to show the dimensions of 10 inches deep. Both of these parts were electron beam melted with Ti-64. And this is a hot air mixer on the naval UCAS vehicle. 2 of those flew on each bird, and every bird that has flown in the demo flights had these in there, including the carrier-based takeoff test about last year sometime. But they had a business case, but we had to make 6 of those to fly 2. So it's an interesting mindset for business folks and the traditional supply chain to understand where does additive really meet the business and the technical. And that's something I'll leave to Ed Morris to talk this afternoon with his talk on America Makes. But it's there for some parts and some applications. It is not the end-all, be-all for everything. You just have to keep that in mind. We view additive as complementary. At IMTS this year, the International Manufacturing Technology Show, Oak Ridge National Labs is teaming with Local Motors and Cincinnati Inc. to produce what we know of, at least today, is the largest by volume structural additive manufactured part. It's a carbon filament with room temp cured resin, and that's the mule test right there. They're driving around in Chandler, Arizona. But this, basically where you see everything is black, is printed, and we've got some external parts that go out to it. So it's not the entire car, including the battery, which it's an EV powertrain. And it's not the tires, and it's not all that stuff. But it's a big section of the car that's structural and has to carry loads. So that's a little bit on additive. There's plenty more. You could spend weeks on this, and people do. The next trend that we saw is also in automation in whole. Robotics specifically, but really automation holistically. So what does that look like? Well, it comes in different formats. You see things like the integrated assembly line in Palmdale for Northrop. I say that again only because they happen to have won the 2013 Assembly Magazine's Assembly Line of the Year for that, where they're bringing more data and more technology to the bird, to the airframe, rather than the airframe following serially all the way down a line. Another things are better ways to move things around, work in process. These are Kiva robots. So it's not just columnar, and it's not just down an X and a Y. These can go all over the place, usually led by either RFID or some laser guidance. We have cohabitation of both humans and robots. People originally, and NIST has been working this a lot on the safety side, well, it'd be great to use a robot. We got to build a cell. You got to put an orange gate up. You got to do all this other stuff. And the business case goes out the window. Well, the fact is you can be smarter about that with data and sensors, instrumentation. And that's what we're starting to see more of. And then pick and place, not novel by any means. They're getting faster, sure. But they're also not segregated and isolated along assembly line. They're becoming more integrated part of the process, both of the fab and of the pick and place assembly. So the underlying feature of all of these is really the big data side. In fact, we used to call the third trend in technology big data. What we realized was it went throughout the entire process. It didn't make sense to talk just big data. So what we have done is kind of broken up. Oh, it doesn't show up too much here. So it's collect, connect, store, analyze, and utilize. These are all the ingredients we think you need for a recipe for adaptive manufacturing. I told you, Larry, we talked about that. We changed it from advanced to adaptive because you have to be able to respond. I know HD last night used the word agility. It's not just time to market, it's your response to those dynamics of requirements. And when you have this stuff, collecting the data, this is the sensor world. If you can normalize that data, all those different sensors talking different language, normalize it, let's say put it in XML format, now what you open up are all the great programmers and coders in the world that are out there doing Android and Apple apps can now get in the manufacturing world without knowing what the machine tool is because everything looks like a web service when you have an XML data output. That's what MT Connect does. Then you store it. Everybody has heard the buzzword about cloud storage, the access that it provides. The traditional thought of what big data meant, the analyzation side, the analysis, the big tools compiled down to one bit of information. But ultimately, we wouldn't need any of these four things if everybody in every instance knew exactly what dial to turn, what switch to flip. In other words, utilizing that data. At the point of information is when you utilize it. If we already knew all this stuff and everything was not a recipe or science to some extent, we would just go do it, but we can't. There's so much data out there, we really don't know what an optimal looks like. In fact, there's probably multimodal optimization algorithms that will show you the solutions for. So it's a tricky world when you start talking big data and how to support things like adaptive manufacturing. But we see the automation world and the robotics world sort of working this as that Internet of Things starts to come to fruition as being one of those key trends that we're recognizing. And the last bit is on transformative technologies. So we're seeing things, people talk about the fourth dimension now of the self-assembly. You can print it, you can do whatever, you put it out, then it does and morphs and changes. You have things like additive with mass customization. Nanotechnology, so not just nanotechnology mechanisms or nanomechanisms, but the nanoscale regime of which you do things. And maybe you design at the nano level, true nano level, but then you deploy it at the micro, macro level, reducing some risk in the environmental and safety hazards and enabling still functionalized product at the end of the line. And advanced materials, that's next day, anytime you switch chemistries, you've got an advanced material. What do we mean by that? We mean that some of these materials that are being more functionalized than ever thought possible. How do you do that? Well, you're getting all this data that we talked about before. You're figuring out what works, what doesn't. But then your product now is the main tributary or main input into your final assembly and production, advanced materials. A lot of those buzzwords and a lot of the stuff I just talked about is tough, if not impossible, for one company, one firm, one industry maybe, to go after. How do you do this? How do you exploit everything that is pre-competitive and then work on your customization as your differentiator later down the stream? In a nutshell, that's kind of what these innovation institutes are trying to go do. And I'm not going to go anymore because I know we've got representatives on this panel. But there's 4 listed here, the top 4. The 5th one was a federal opportunity announcement just made earlier this year for composite materials. Since I'm not a public official, I can speculate. I speculate that we will see something in the realm of these 3 potentially coming down the pipe. Something in advanced robotics and automation, something in the data centricity. Again, maybe it's a little bit big data, maybe it's DMDI with another small change or flavor. I expect a lot of these innovation institutes are going to talk to one another a lot more than what people imagine. And then nanomanufacturing. Again, nanomanufacturing may not be manufacturing at the nanoscale. It might be development and design of elements at the nanoscale that then gets deployed on the macro. So that was a quick overview of kind of what we do at AMT, one of the segments of what we do at AMT, how I've kind of captured that as we follow these trends and look forward to the questions a little bit later today, but I think that'll be it for me.
Great.
Appreciate your time.
Thank you, Tim. Okay, so our next presenter is going to be Dan Hartman, and Dan is the Digital Manufacturing and Design Innovation DMDI program lead for Rolls-Royce in Indianapolis. And he's also, in his DMDI role, he's responsible for managing the Rolls-Royce activities within the DMDI Institute. Daniel is also on loan part-time from Rolls to the DMDI Institute as their Director of Program Management and Integration. Dan joined Rolls in 2004. He's had several engineering leadership positions, including manufacturing engineering, manufacturing systems, measurement systems, and operations capital management. He led the implementation of NX PLM CAM system. He's managed the development, implementation, of support of various manufacturing and measurement systems, automation, and IT projects within Rolls-Royce. He's got 28 years of manufacturing experience in CAD/CAM and NC programming systems, and lean manufacturing and Six Sigma. Before coming to Rolls, he was head of engineering for North American manufacturing headquarters of Still Incorporated, where he's responsible for all engineering functions. Before Still, he was head of advanced manufacturing engineering for Honeywell Aerospace Aircraft Landing Systems, where he implemented numerous manufacturing automation technologies. And early in Dan's career, he also worked for the Department of Energy in the nuclear weapons facility, developing multi-axis NC programming systems. He has a BS in numerical control technology from Northern Illinois University. And this was a great condensation on his resume. And I think that was part of the hardest part of my job, is introducing these fabulous people who have resumes that are literally like 9 pages long, and I'm thinking, how can I possibly do them justice with all the things they've done? But Dan, we'll turn it over to you.
All right, thanks. I don't have any slides. I'll just try to chat a little bit, but that sounds a lot more exciting than what my career has actually been. I'd like to get a copy of that. That sounds pretty good. I'm just an old manufacturing guy, a chip cutter. I lived 27 years of my life on a shop floor, implementing new automation systems, new programming systems, new robotic systems, any type of an automation, applying computer technology to the shop floor to save us money in many different industries, product lines, several different challenges. About a year and a half ago, an individual out of our design systems engineering group called me up and said, hey, we've got a meeting over at University of Illinois. We're meeting with them about their endeavors to go after this DMDI Institute project. And they wanted me to go in and provide some manufacturing input and advice to it as to how they're going to join this team. So I went along, and it piqued my interest immediately. I mean, this was going to be one incredibly exciting project, and Rolls-Royce was ready to sign up all the way. So Rolls-Royce was exclusive on the UI Labs team. Many other companies around the country were on most of the teams, making sure that they would be on the winning team, but Rolls-Royce and a few others were exclusive with the UI Labs team, as we were pretty confident this was going to be the winning team. So then late in the year, when we were switching gears to finishing off the proposal, I got a chance to move over into the engineering group, actually get off the shop floor for the first time in nearly 30 years. And they asked me to lead the whole program for Rolls-Royce. So I'm now responsible for everything that happens within the DMDI Institute within Rolls-Royce, managing all of our projects, coordinating all the different project hopper, things that we're putting together, the organizational structure that we're putting in place. And during the proposal, then the UI Labs team also came to Rolls-Royce and said, hey, we'd like Dan to be part of the UI Labs team in the Institute. and we'd like him to be this director of program management and integration. So I actually have to somehow live 2 lives. So I'm trying to run everything within Rolls-Royce, but now I have to run everything, run all the projects and everything within the Institute. So it's supposed to be a 60-40 split. I'm 60% dedicated to the Institute, 40% to Rolls-Royce. The most difficult time is trying to make sure that that stays percentage and not turn to hours every week. Things are getting quite busy and hectic for us. From the Institute side, we are in the process of standing up a facility in Goose Island. We're finishing off all of the design details and planning for that. Hopefully we'll open up in February. It will be a state-of-the-art manufacturing facility. We will have about 30,000 square feet on the shop floor for doing demonstration of any kind of advanced manufacturing and digital technology. There will be classrooms, training facilities, everything, project team area, war rooms, all in one dedicated facility to the digital lab. DMDI is centered around 3 core technologies, and Tim touched on some of these. Some of your slides actually would have worked for me. It was good. 3 core technologies. Advanced analytics, which was some of the big data and things that Tim was talking about. So how can we harness potentially unlimited compute technology? So University of Illinois has the Blue Water supercomputer. That's the backbone of the Institute. So if you have a compute power like that, what could you do in a virtual design and simulation arena? For example, from a Rolls-Royce point of view, we would like the ability to simulate a subsystem or eventually an entire engine and be able to vary within the dimensional constraints of every component and its impact on the performance of that engine. I mean, that's a monumental computation task to get to that. The other technology thrust is on intelligent machines. So Tim mentioned some of this as well, some of the sensor technologies, MT Connect, some of those things from getting data from the shop floor. So tying all of that data and information from the shop floor and eventually from service as well. Getting all that data, all that information back together for decision making and deriving the next level of products. And then the third one is advanced manufacturing enterprise. So that is the connection of everybody. So connecting an entire supply chain digitally. Okay, so tying everyone together, working off of the same data model. So no matter which OEM or where that original model comes from, that is the master model. All the information, everything embedded in that model, and everybody in the entire supply chain working together using the same data model. No more sending drawings around, emailing this, that, everybody working off of the same piece of information. And all that information from their shop floors, all the sensors in your supply chain, everything tied back into the same data repository, some of the cloud-based storage that Tim mentioned for me. So those are some of the key technology. I think we're going to touch on some more things through the other sessions here. From the DMDI side, it's very exciting. I'm happy to be here. I try to answer whatever I can in the question and answer session at the end. Okay.
Very good. Thank you. All right. Our next presenter is Kimberly Gibson. Kim is the Communications Manager and Workforce Development Liaison for the American Lightweight Materials Manufacturing Innovation Institute, ALMMII, ALMI. If I'm pronouncing that correctly.
You did great.
It's one of the nice things about all of these NNMI centers, we've got a whole new list of acronyms for everyone to learn.
We are rebranding, by the way.
Right.
That's what happens when you let an engineer name something.
Okay.
You know who you
so
are.
Kimberly comes out of Edison Welding Institute, or EWI, into this new role, and she's learning how to endure the drive up I-75 all the way to Detroit. In 2009, she launched the Energy Center at EWI, And as director of that, she partnered with companies to accelerate technologies development from prototype to commercialization with a special focus on manufacturability of advanced energy technologies. She's also worked with clients to reduce manufacturing costs, reduce energy intensity and waste streams, and to assure U.S. manufacturing remains competitive. Most recently, she was a founding member and launch executive director of Advanced Energy Economy Ohio. As an energy advisor to former Ohio governor, she assisted in the design and implementation of the state's energy policy, led implementation of Ohio's $150 million advanced energy job stimulus package, deploying low-interest capital into Ohio energy companies for technology maturation and scale-up. In 2002, she returned from Washington, D.C., where she was an analyst with the Brookings Institution Center on Urban and Metropolitan Policy, and while at Brookings, worked with top scholars in the field of transportation, regional economics, and metropolitan change. Currently sits on the Technology Commercialization Review Board of Ohio State University College of Engineering, where she was formerly an adjunct professor in city and regional planning. She has passion for seeking new ways to craft excellent communities through the degree of adaptable and sustainable systems, and serves as strategic director of the Center for Resilience at Ohio State, bringing forward the resources of the university to assist manufacturing to be more resilient. And since she's moved to Detroit, she has not yet become a Detroit Tigers fan, but she's willing to listen to anybody from Detroit that wants to talk her into that. And she tells me that she also spends her evenings either learning how to pilot small aircraft or singing in a funk band. So I don't know if like any of you people play bass or something, but maybe we could get something going here right after if we have time before lunch, okay?
Thank you.
All right. Kim, great.
What a pleasure. So I hope you don't mind. I'm just going to sit here if you don't mind.
That's great.
Hanging out with everybody. The lights are lovely. It's nice to be with you all today, and thank you, David, for the invitation. I'm pinch hitting for my colleague, Executive Director Larry Brown. So sorry you have to put up with me today. A little bit about the Lightweight Modern Metals Manufacturing Institute, which was the project name given to it by the military. How many of you know what the NNMI institutes are? All of you know what they are? No? Okay, so the National Network of Manufacturing Institutes was an initiative put forward by the Obama administration. They did some studies in the first half of that administration looking at where are the gaps in the United States for innovation and how to pull that innovation forward. And what they found was there's a real need to look deep inside our universities, our national labs, and our communities to find the invention that's kind of latent but ready to be pulled forward, and to have a very deep expertise in that. And so crafted a vision for a network of these institutes. And I won't go into the politics of it, but there's 4 of them now. So we'll see how far we get. The president's vision was 15. Sherrod Brown, U.S. Senator Sherrod Brown, just earlier this week introduced a bill that would fully fund the NNMI program. And it passed out of the House committee. Yes, I said the House committee, in case you weren't listening. So who knows what might happen there. And the importance of these institutes, I think, are really to find that place in the gap. Here you see the concept of technology readiness levels, where technology has been demonstrated at bench scale perhaps, but it needs to move forward into the private sector. It has to have an application. It has to be pulled out of the latency phase. This is where most things die, right? And so there's been a great deal of global competition, especially from countries like Germany. Taiwan is in the game. Singapore, Malaysia, Lots of other nations have realized that those nations that have the manufacturing, hey, there's a lot of innovation here that occurs on the factory floor. America's always had a competitive advantage in these things. So the concept of the NNMI, and the one that ALMI took to heart, was how to look at technology readiness level 4 through 7. You see how to develop the technology, the demonstration of it, and then the subsystems that go along with it. And that's where ALMI sits, right in that space. A little bit about the institutes and how they are formed. ALMI took this to heart as well, looking at doing that applied research and demonstration for different projects, as I suggested, but also integrating that technology, developing methodologies and practices that can be pushed down into the supply chain, and doing that in a very short window, no more than 3 years. In addition, no one is ignoring small and medium enterprise, though small and medium enterprise can either be very innovative or they can be laggards when it comes to adopting technology. We see them as partners in this endeavor, and our original equipment manufacturers, who are our large members of ALMI, also see them as very important. And you're going to hear more from Terry about this, but we also very much view education and technical skills and workforce development as a critical piece of our mission. Because you can create a lot of different technologies, but if you're not minding the gap in how those get implemented into the schools, the technical colleges, and into STEM, you're really missing the boat. And I think we've had many years of missing the boat, trying to catch up to it, and doing our very best. I don't think any of us want that gap to get any bigger. And so ALMI is positioning ourselves to make sure that gap doesn't get any bigger, and that it's right as the technology is being developed, it's also being transferred into the schools. So just a moment about lightweighting. Certainly, lightweight materials enable you to reduce the weight of a product. It's particularly important in the transportation sector. It can improve survivability, affordability, definitely performance. What we're finding is the paradigm between light versus heavy is completely different now. You can have a very light thing that's even stronger than a very heavy thing. And our team is extremely excited about those possibilities. And when you start talking about additive materials and different powdered techniques, we can just do so much now, and there's so much more we want to move forward to. Weight reduction is critical to our defense systems. It's also critical to our transportation if we're going to meet those CAFE standards, and all of us driving cars want to make sure we get the biggest bang for our buck, especially if you're buying that 93 octane for that sports car. This will help and impact your life every day. A little bit more about what we're calling the Lightweight Modern Metal Manufacturing Innovation Project, LM3I. Of course, ALMI is the newest addition to the mix here. We've spun off a new not-for-profit 501c3 company. It was started by EWI, the Ohio State University, and the University of Michigan. Yes, I know cats and dogs lying together, but it actually worked. Everyone saw their mutual self-interest here. And these three entities spun out a separate company, and it's called ALMI, to run this project and move it forward into the future. And EWI is performing the back office function. Back office includes everything from project management to administration. Now, that's not very sexy to talk about, but lest you think that you have people who don't have experience working together, this is a proven team that has a lot of 30 years of experience working together, doing projects and getting things move forward. That's why it's important to mention that in this forum. So with respect to our partners, none of this happens without industry. This is an industry-led, government-advised operation. These are some of our partners in academia, very large companies. You also see we have a number of workforce development agencies and organizations from community colleges and a variety of intermediaries. We have other nonprofits that are nationally focused associations, professional societies, and of course our SMEs. So this is a very diverse organization with a lot of different interests. But our number one interest is really serving the United States manufacturing sector to pull that innovation forward as it relates to lightweight metals. Now, economic impact is important, and I only put this up here to share with you that ALMI's main focus in these early days is the 5-state region along I-75. From Michigan all the way down to Tennessee. You have Michigan, Ohio, Indiana, Kentucky, Tennessee. These states contain 70% of the entire country's metal processing, fabrication, forging. The metalworking industry, 70% of the metalworking industry is in these 5 states. That means you have a lot of stranded costs and assets in those states. You also have a tremendous amount of talent and knowledge in those 5 places. So as we looked at the landscape and said, where are we going to locate this thing? It made so much sense to do it in the heart of America. And in fact, just last week, we announced that our new home will be in downtown Detroit, on Rosa Parks Boulevard, not far from the old Detroit Tigers Stadium, which is not in the best shape at this time. So we are part of revitalizing and completely remaking an area of Detroit, utilizing new technologies. So we're excited about that. ALMI is also very important to us as technology transition, because if you can't get it out of the lab and you can't get it into industry, there's a lot of effort wasted. So we have a very rigorous intellectual property management plan. We have, when you do a project with us, you have to have a plan in place to use it from day one before you get a penny. You have to think about IP and certainly how you're going to push that into the marketplace. And a little bit about our process, we also consider workforce projects important, so we'll be embedding students, postdoctoral candidates, and others who want to learn from industry into these projects to make sure that the knowledge that's gained from the innovation that's created is also distributed throughout the organizations that are participating. Again, I keep bringing up education and workforce. That's the other half of my role, so I think it's really important. We are looking at a total effort that also includes K through 12 and STEM. I mention the community colleges continually because I think they are central to this mission. Continuing education as well as workforce development agencies. We're also connecting with locally relevant, like economic development organizations. These people have a tremendous amount of knowledge across the country. And we're really trying to integrate and look at the very best practices across states. Kentucky has some good things that can be shared with Indiana. Indiana has some good things that can be shared with Tennessee, so on and so on. And ALMI sees itself as a convening force to ensure that collaboration is happening and ensure that the lightweight metal sector is being served across the board. So that's a kind of a different approach than I think you've seen in other places. Now for the really juicy stuff. This is our technology scope. We are focused on priority metal classes and alloys, advanced high-strength steels, titanium, aluminum, and magnesium. And we're looking at technology development, which we have grouped into 7 pillars. And you can see those there. For purposes of our audio, I will read them off. Novel metals, melt processing, powder processing, thermomechanical processing, novel processing, coatings, joining, and assembly. Now, each of these, as you know, have tremendous amount of opportunity within each sector. And as you're thinking about transportation in general, this runs the gamut. For that reason, we also have cross-cutting themes. These themes really do impact all of the technology development across. And so we have leaders that lead the cross-cutting themes as well. Integrated computational materials engineering is a very important methodology that we're utilizing. Computational modeling has grown our ability and the power of computing. We have DMDI here. We'll be working with them on some of this to ramp it up. But the idea is to do as much of this as we can on virtual paper before we have to go and build stuff and blow it up and tear it down and figure it out. The other things are design. Certainly, how do we make designs that are repairable, resilient, adaptive, and can also be repurposed at the end of their life. Life cycle analysis, how long is it going to last, among many other things. Validation and certification. How do we look at how this thing that we're making today and this technology will be validated and certified? What kind of tooling and processing is going to be needed on the back end? We don't want to create this great technology that nobody can make. Cost modeling, enough said about that, right? Supply chain, how do we penetrate the supply chain in a particular sector? What are the implementation issues for that? Certainly corrosion is always an issue when you're talking about metals. Alloys are certainly no different. And then ballistic testing. These are, I took the time to go through this because this is, the core of what we're doing technologically. And the processes and the procedures are a means to make sure that these important things get out as rapidly as possible into industry. Now, I want to mention our non-industrial partners here and the way ALMI thinks about this. As I mentioned, the I-75 corridor is the focal point, and it's where most of the industry is located, the assets and the workforce. But there's capability all over the country. And you'll see on the slide here a number of facilities that we're using for different capabilities that they have. And the ALMI headquarters in Detroit will have the capabilities to prototype and scale up production that these largely university areas and centers do not have. So we view ourselves as, while we're making physical products, doing actual research in manufacturing, which is very expensive and capital intensive, we are spreading the love around the nation, and we are pulling it all together in a project management scheme. So that's the idea behind this that makes it different than anything else that's going on right now. So 90 days startup. I think our 90 days ends tomorrow. And we have had a few glitches. We had a 60-day delay in getting our building lease signed. And if you want to talk offline about that, I'm happy to commiserate. But we did finally sign that lease, and we're delighted about the building. We have all the procedures and processes in place, and we've already got something like 11 projects that are under review, and we hope to be making some announcements here in the fall. So the group is moving very quickly in 90 days. When President Obama announced us February 21st, I think it was. It's been a wonderful spring and a wonderful summer so far. So I'm not going to go into the structure. I think that's boring, but there's a core group of people, and they're doing a lot of stuff. There's a control board that makes the decisions, and then there's a government organization that's separate that gives feedback. So this is really industry-led from A to Z, with government input and government funding to share the risk. That is the central foundation. And then you have the organization of EWI and its 30-year history of running projects and doing innovation, holding it all up. That's essentially what ALMI is. And these are the principles. Thank you.
Good. Kim, thank you very much. All right, so our next presenter is Larry Knauer. And it's interesting for Larry's sort of new career. He's really looking at additive manufacturing as a way to help him develop a new product that he's working on. And it's interesting to see because to me, one of the most exciting parts about additive is that it's not making the same part that you already have. It's making something in a way that you could not make it except for additive. And to me, that's just a tremendous advantage. And maybe it's oversimplification, but I think if you saw Greg Morris this morning talking about that fuel nozzle, it not only replaced 20 parts into one, but it's doing the job in a much different way than currently functions. And that's the real beauty of it. So if you currently make a part, with traditional method, maybe just making that part again in additive is not really the answer. It's totally redesign of the part. So Larry is currently president of HSSE Holdings. He's developing a hyperbaric steam Stirling engine for the combined heat and power market. Before launching that, he was with Lockheed Martin. He's recently retired from there. He spent 26 years in numerous management and engineering positions, including he was director of propulsion systems for Lockheed Martin Space in Littleton, Colorado, where his work covered systems ranging from micronewton electric arc jets up to 1 million pound thrust solid rocket motors. He was director of small payload integration for Lockheed Martin at the Michoud facility in Nolens. I can say that because we have a son that lives there. So, he also spent 6 years at Pratt and was president of Pratt & Whitney Space Propulsion and Russian operations. Interesting stories about working with the Russians back in the day that might be a little more awkward in today's environment for sure. He's a master's degree in management science from MIT, a bachelor's of aerospace engineering from Georgia Institute of Technology, and he holds a number of patents in the propulsion field. Larry, turn it over to you.
Thank you. I appreciate it, Dave. There's two things you can take from that resume. Either I can't hold a job, or I'm staying one step ahead of the law. I'm not sure which. Anyhow, I'd love to be in your staff meeting in the third week in November. That's got to be exciting, leading up to that Saturday after Thanksgiving. Yes, I can't imagine Big Blue and the Ohio State being in the same room at the same time that week.
It's going to be interesting.
Good luck with that. Okay, so we talked a little bit about additive manufacturing, advanced manufacturing, and Tim mentioned the word that we talked about last night, adaptive manufacturing, and H.D. Stevens, added the word flexibility. So, what we're really talking about here is a flexible, additive, adaptive manufacturing process, and we're really focusing on what are highly tailored engineering products. And when you think about what that means, is we have to think totally differently about how we address certain critical issues that range from getting product built, qualified, validated, and certified, to developing the technicians you need or the critical skill labor you need in order to get the work done. So I think we're needing to think now about what is the future going to look like, and can we afford to live as we've lived in the past? I don't think you're ever going to do A-base allowables on some of these products. It's just not going to happen. Give it up. Sorry, metallurgists, but it's not practical. And I'll give an example of where we've done that in the past and been quite successful. For my particular application, what we're looking at is a need in the distributed power community. Department of Energy says that there's about 10 gigawatts of distributed power in the 1 to 20 megawatt power range that needs to be installed annually, and that's growing at about 20% a year. So huge market, huge opportunity that's being addressed, but not being addressed very well. And I'll talk a little bit about that. Just in the state of Ohio, as an example, there's over 2 gigawatts hourly that's going up the smokestack in either waste heat or waste fuels that could be put to plant use around the state of Ohio alone. So multiply that times the rest of the industrial stations, you can see that 10 gigawatts is probably low by a long ways. The worldwide market probably is closer to 100 gigawatts annually in the 1 to 20 megawatt range that needs to be installed for either industrial applications, residential, hospitals, whatever, universities, et cetera. So That's the market potential, and oh, by the way, that doesn't affect the grid at all because it's all behind the fence kind of stuff that needs to be put in place. The grid is growing at such a rate, power needs that they could actually use to have some of this stuff come off the grid to balance the grid better. So it's actually synergistic and helpful across the national grid as well. Enough of that, but let's talk a little bit about the business case and the rationale for these adaptive manufacturing systems. Most combined power and heat projects require you to go into a plant or into a facility and look at what are they doing today with steam generation, what are they doing for power generation, what are they pulling off the grid, what are they using, what are their exhaust products, et cetera. And every plant is different. So if I go into a sewer plant in Youngstown, Ohio, it's going to have a total different energy thermal balance than if I go into the steel mill just down the street that's making advanced steel products. Both have an internal need, both have substantial waste heat, both have substantial power needs that could be leveraged and lower their overall costs. So why isn't more of that going on? Well, the reason more of that's not going on is because of that thermal energy balance equation you got to go in by each individual plant. So if I go into a plant and I say, okay, I'm going to look at your balance, I'm going to look at what you need, and I conclude you need so much steam and you need so much electricity, and then I'm going to go build you a power plant to go manage that. In today's environment, what we're doing primarily is we're bringing Caterpillars or Solar Turbines or some of these smaller, they're big, don't get me wrong. The Caterpillar 1 gigawatt power station won't fit on this stage, so that, it's not small by any stretch of the imagination. But what we have is these products are all developed around a specific engine, prime mover, that was developed either for a specific application, typically not an application originally designed around terrestrial power. They were a Caterpillar for a big earth mover, or some other application. So or Yanmar for a big ship application. So these engines were designed around a specific application. Well, then that sizes the product and where what you're going to do and what you're going to be able to do with that product. So if you want to operate that in a given operating zone, a given efficiency, you're limited on what you can do with that particular product when you come in. So if I go into a plant, let's say, and I need a 1.65 gigawatt megawatt power plant, and I need so much thermal load coming off of that, and I go to see what's in the catalog to go buy or go try to put the system together. I go pull a CAT off the system, and it's a 2.1 megawatt system. The next one down is a 1.35 megawatt. I got to go to the 2.1 because the 1.35 is not big enough. So now I've got excess capacity that I'm putting in, so I'm paying for that excess capacity. In addition, now I'm going to operate it at 75% of its design load, and it's going to be less efficient. If I drop it 25% off the design load, it's going to operate at about 20% less efficient. So now my fuel costs go up by 20%. Fuel costs on the CAT power generation, as an example, represents about 65% to 75% of the cost of operating that engine. There's maintenance, and then there's the capital depreciation as the other costs. So I'm ending up with a less efficient system, and I paid for capital that I'm not using. And so what happens is I now end up with a business case that doesn't close. I can't go into that 1.65 megawatt facility and provide them a product that's affordable any longer. So this is where the adaptive piece comes in. If I could actually make an engine, a power system, complete from start to finish, that matches each individual thermal load and each individual power need, I can optimize and operate more efficiently. I can't do that today because, for example, the Cadillac Northstar. Anybody have an idea what the non-recurring cost for the Cadillac Northstar was? Take a rough guess. Cadillac's cost was about $150 million. Their suppliers had another $100 million. So almost $250 million in that engine. You want to know why there's only a limited variation on North Star? That's why. You got to build a lot of North Star engines to recover $250 million worth of non-recurring cost. Now, they get it because they've got a lot of volume in automobiles, they can do it. You don't have that much volume in things like distributed power and those kind of things. So yeah, there's you might build 1,000 or 10,000 total plants, but they're all not going to be the same. So your market might be 1,000 total in a given size range. So again, you're not getting that leverage. You'll never pay off an engine development that's $200 million. A small turbine, anywhere from 50 to 150 million, upwards to 300 million, depending upon the size of the turbine, type of turbine. Like a new CAT engine, typically they tell you 50 to 100 million to develop a new CAT engine. So building an engine specific for an application isn't practical in the way we do things today. That's where the advances in adaptive manufacturing could become a breakthrough, but that creates a whole set of new challenges for us as we're going forward. How do we then certify, validate, and qualify these systems going forward? There are certain things that are scalable. So within ranges, you can scale and build things pretty effectively from a scalability standpoint. So if I can build a small engine, let's say in the 1 megawatt range, and I can scale it up to 2 megawatts and down to a half a megawatt pretty effectively, the components are pretty much the same in that size range and what you're talking about, and the basic principles are the same. The designs really are pretty scalable in that kind of a range. So you can build ranges where you could be adaptive. But now, how do you qualify and validate an engine that could be 1.25 in one case, and the next one coming off the line could be 1.5? So what's the certification validation process? One may have a 3 3/4 inch diameter piston, and the other one may have a 3 5/8 diameter piston. So is that enough to drive a new qual, a new cert process? In today's environment, it is. Is that the environment that we can afford to live in the future? That's the question I'm putting forward. How do we get to thinking about when and where do you need to go through a full requal, recert, revalidation process, and what does that process look like? So that's the challenge I think that we have as an industry, is how do we, if we can break that chain, we can significantly change the numbers of products and the availability and the marketplaces in many areas. I just gave you the one that I'm currently focused on, which is the distributed power, the combined power and heat market, but this applies to everything. It applies to automobiles. If you could go in and tell Cadillac, hey, you want to change your design and you want to, instead of a 300 horsepower, 5.7 liter North Star, you want to use a 4.3 liter 150 horsepower engine to get your mileage up because you got your weight down, you can now do it. And so that's the opportunity that's out there, that if we can figure out a way of doing that and allowing us to take a fixed set of design parameters, going and validating and certifying and qualifying a family within a range and not have to do each one individually, we could save huge amounts of costs and also find ways of, because one of the big costs is actually the tooling and getting the non-recurring tooling set up for these large production runs. And so of that $250 million that I talked about for the North Star, a little over a third of that is just the non-recurring tooling costs that drove that. So that's one of the advantages that additive brings to the table, is hopefully we can reduce those tooling costs substantially through the additive manufacturing. So the question then is, okay, what about validation? What about qualification? What about certification? If we think of these as terms as highly engineered, highly tailored products, and each one is going to be slightly different coming off the line, how do we get to the approach where we have what I would call a systems approach to accepting product hardware designs that are coming off of these kinds of capabilities. As I said before, we can't afford to think about A base allowables, B base allowables, the historical things that we've done in the past in order to certify metals to go into application for use. We found a way by those of us in the aerospace industry, and now it's all over the rest of the industry. Early on we found a way of doing that for composite materials. We didn't have A-base allowables on composite materials. You had no way of knowing because each laminate was different, each structure was different, but we found a way of verifying the matrix, verifying the fiber, and then being able to analytically build up the part and certify it that way with a test. So those approaches are out there. We've done it in the past. We know how to go do it. The one that I worked on specifically, we took aluminum lithium 2195 from a laboratory ingot in 1994 and flew humans on it 4 years later on the space shuttle. We did not have A-base allowables. We did not have fully certifiable product when we did that, but we found a way to do that and to develop a series of processes that became acceptable to NASA and to Lockheed Martin as a way to go make that happen and pass through all the safety review boards and whatnot to go drive that. So it's going to take a different way of thinking about how we go through and not letting, I hate to use the word bureaucrats, but not letting the bureaucrats drive the process so that it says, well, wait a minute, in order for you to pass CDR, you need to have A-base allowables or you can't go forward. Well, okay, that's not going to work. I mean, if we allow ourselves to get locked into that, none of the things we're talking about on this stage will ever happen. So there are ways of doing it. We know how to go do it. The challenge I put forward is you got to just accept, and what we ended up having to do on the space shuttle program is said, we got 4 years to go fly this. What's it going to take for us to get to the point where we know we're going to have 100% success? What is it we have to go do to come up with and satisfy ourselves and the NASA customer that yes, this is indeed a product that is safe to put humans on and go to orbit. And that's the kind of thinking that we're going to need on all of these products, because if you really want to have a tailored material, a highly tailored, highly engineered product, you're going to build it differently. So I would anticipate, for example, a Pratt & Whitney fuel injector to be totally different than the GE fuel injector. And I would anticipate that you're not going to use the same product validation and that they're going to be built differently. And so therefore, you got to have a way of certifying the product for each of those particular applications. You can't certify the metal because the way that Pratt does it might be different than the way that GE did it, and therefore it's going to result in different material properties. How do you validate that going forward? And so that's the challenge. I believe it's going to require more build and test. I mean, we heard earlier about building 6 to get 1 or 2. That's essentially what we did for the super lightweight tank program. We basically built a full-scale test article and broke it, find out how it would break, and then we took that and developed a protoflight test for every tank. Every tank went through basically 120% proof test margin for both loads and pressures to validate that it was a good tank before it left the factory. Different way of doing it. That's a different way of certifying. You're certifying by test rather than by data and analysis. So again, I challenge you as you're looking at these things to think about, and maybe we can have more dialogue about this, about how do we get to a totally different way, but not different than what we've done on other materials of doing the qualification, validation, certification. And that leads then to the skills and skill development, the people you need to go run this equipment. And run and build this hardware. Today, most of the hardware we see being built and things being demonstrated are being built by PhD metallurgists. And they're great guys. They're running these machines. They know what they're doing. But you're probably never going to get to a stable process with a PhD metallurgist running an additive machine. They like to tweak. They like to invent. They like to explore. So getting a stabilized process probably isn't going to work. Are these people going to be welders? Are they going to be machinists? Are they going to be millwrights? What is the tool set going to be that we're going to need to operate these machines? We went through this once already with the automated six-axis machining processes, so we know how to go do this. But now is the time to start laying out that groundwork of what's it going to be, how are we going to work the handoff between the PhD metallurgist down to the guy who's actually going to go build the 10,000 parts on these machines as we're going forward. So that's the challenge I think we have to work forward. I think, again, we've done it before. But there's great opportunity here for a whole new set of skills, a whole new set of training, a whole new set of development to take place. And I kind of liken this to in Ohio. We had about 10,000 people lose their jobs in the Akron area when vinyl records disappeared. Vinyl record business was about $1 billion a year business worldwide. CDs came into place and totally wiped out the vinyl record business. But within 3 years, the CD market was over $6 billion. A six-fold increase in market because of the ability to produce things better, faster, cheaper. Some of those 10,000 workers got retrained and were building CDs.
What is a CD?
Things. What are a CD?
Yeah.
That's right. And so now we've replaced CDs with MP3s, and now MP3s are going away with the cloud. So again, and each time that happens, we've seen a doubling or tripling of the market availability and the sales in those markets. So the same potential is here, I think, with what we're talking about. Thank you.
Good, thank you. Great, and very nice segue there, I might say, to our next speaker, to Terry Burgess-Sandu. And you talked about workforce, and I think anytime we have any of these discussions about advanced manufacturing and what are the need areas, workforce is always on everybody's list. And so glad to have Terry Burgess-Sandu on the panel today. She's director of the Entrepreneurship Innovation Institute and executive director for workforce development at the Lorain County Community College. And she has more than 25 years experience in community services and economic development. Within the EI umbrella, business serving decisions including Lorain County Small Business Development Center, the University System of Ohio Talent Development Network, and under her leadership, the college facilitates talent and workforce strategies for the Northeast Ohio Speed to Market Accelerator. Recently led a statewide initiative with 11 community colleges to expand collaborative approaches for meeting the talent needs of Ohio's advanced manufacturing sector. Previously, she held positions of executive director and development director for Hard Hatted Women, program director at Common Ground in Oberlin, Ohio, assistant director of Head Start and development director of Lorain County Community Action Agency, planning and research associate for the Council for Economic Opportunities in Greater Cleveland. And she's on the executive committee member for the Construction Diversity and Inclusion Initiative, led by the Greater Cleveland Partnership. She's a 2011 recipient of the Excellence in Workforce Development Innovation Award from the Ohio Economic Development Association for her work with the Ohio Energy Workforce Consortium. And Terry has a bachelor's degree in political science from Oberlin College Leadership Program. She's also a licensed auctioneer in the state of Ohio, and is the owner of 2 small businesses. So, Terry?
I'm going to stand. And I recognize I'm between you and good questions, so I'll be fairly brief. I wanted to just talk a little bit about Lorain County Community College and set the context a little bit about what we do. That college is about 30 miles west of here, and we are a manufacturing community. It is in our blood, it is in our DNA, and we very much represent the transformation that's happened in manufacturing. Back in about 1980, manufacturing represented about 43% of our workforce. So there was a long history of people graduating from high school and walking into their dad's jobs or their uncle's jobs, typically not their mom's jobs. Today, manufacturing represents about 13% of our workforce, but it represents the same economic value to our community. So it is all about technology and advanced, adaptive, call it what you will. It has massively changed, but our college really has been committed to advanced manufacturing. It has remained deeply committed to recognizing that we have to be a partner with companies and with our students and with parents in our community to understand what is happening, how do we adapt, how do we help companies keep pace with this technological revolution which is continuing to happen, and how do we help those in our community who are looking for what role they can play in that economy find that place. Our strategic plan represents that commitment. You can see that we, typically people often think of community colleges, you think, okay, they're gonna provide associate degrees for folks. Definitely, that is a core part of what we do, but you see we also are very focused on not only helping to prepare talent, but how do we help create jobs. So when you think about the commercialization spectrum, we're very much in the place of how do you apply a lot of the research that you all are doing, a lot of the thinking that's happening. Bottom line, companies and entrepreneurs have to figure out how do you get that technology into the marketplace? How do you help our students learn how to apply that technology? Just briefly, we have a wide range of programs from K through 12 all the way up through master degree programs. We're proud that in our county, in Ohio, we have about a 5% average of students who are graduating from high school with some college credits in their backpack. In Lorain County, we have 20% of our students, and that's due to a very robust system of school by school, district by district, partnering with schools to make sure that students are making full use of dual credit options. And in Ohio, we now have a new law that has just passed for college credit, so that you're going to see that growing. We also have what's called a university partnership program, so that we can, again, help our students who tend to be place-bound adults. Majority of our students are part-time students, working adults. How do we help them continue their education to get their bachelor's and master's degrees to fill the high-skilled needs that companies have? And I wanted to talk about that because it's definitely relevant when you talk about the skills gap. How we address our Vision 2.0, you'll see in here we have a very robust ecosystem for supporting entrepreneurship. And I wanted to share that because a lot of what I live and breathe and what we live and breathe is definitely in the arena of advanced manufacturing, advanced technology. My particular unit, the Entrepreneurship Innovation Institute, our customer is company. So is companies. My job is to really sit at that intersection of what's going on in the economy. How do we help companies adapt and survive? How do we help them think about their talent planning needs, meet their talent planning needs, and access all the resources of the community, not only Lorain County, but regionally and statewide? I won't go through all these services. I will talk a little bit about we have a commercialization center that is serving a national market, and it's very much in the space of sensor development. And again, the application of research coming out. How do you help companies who want to use new sensor technology and apply it for a commercial application? So if you would like more information, I'd be certainly happy to talk with you about that. This just gives you a little more information about Northeast Ohio, if you're not from the region, to know, again, it is in our blood. We live and breathe this, and we're very excited to have America Makes in our community. Lorain County Community College was actually one of the partners who helped to win that award, and we are a member, and we are working hard to stay abreast of what's going on there and contribute where we can. In terms of what's going on with talent and how does all this translate to the bottom line, and what we all need to know, what our children need to know, what our community needs to know, the workforce crisis is real. I'm not going to go a lot into the information because really all you have to do is go into Google and type skills gap. And lots of studies and reports, lots of really nice infographics that are much fancier than I could produce will come up. There are a lot of people thinking about this nationally, a lot of really smart people. And those of us on the ground are then trying to figure out, okay, what do we do with this? How do we really drive this forward at the community level? School by school, company by company. So it's just some of the statistics, you can read them. They should keep you up at night if you're a company who has to think about talent. And hopefully my goal would be to, if you're not already engaged in some level of partnership around these challenges, please, I hope you will leave inspired to become engaged. because this is truly a national challenge and it is going to impact our ability to compete globally. These are just some of the numbers. I mean, this is, these are statistics coming from companies themselves that are being surveyed on a constant basis from groups like Accenture and Manufacturing Institute. You have the link if you want to go. There's a really nice infographic that NIST has, the National Institute for Skills and Technology. And I talk fast, that's why I'm an auctioneer, so slow me down if you need to. Really, what's going on is really simple. There's dual forces. We've got an aging workforce. When you're talking about highly skilled, whether you're talking at the engineer level, PhD level, and the machinists, the tool and die makers, those folks are aging. And we have not, as a society, been filling that pipeline. We've really underinvested in vocational education. We've undervalued it. The communication to parents has been college, 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 not recognizing that college can include career and technical. Students who go into career and technical in high school, so there's this whole societal force. We know there's challenges with STEM education. All of these things are happening at the same time as those folks who are in the workforce with those skills are aging and beginning to think again about retirement. A lot of folks put that off when the economy crashed. Now people are starting to feel confident again. So there's some uncertainty around timing, but it's real. We know the numbers. Companies are tracking their demographics. At the same time, we've got the forces of technological innovation. So I sit here and I know that there's 4 innovation institutes, and I'm already having trouble keeping up with the one in Youngstown, which I can drive to. I have no idea how I'm going to keep up with the other 3, much less if they go to 15. So we really, again, from a design perspective, I need help. My colleagues need help. There is just too much data coming at us, and we've got to figure out how to be smarter about getting that information and applying it in the real world. This is another one of those great infographics. You probably can't read it, but you can go to this. You can go to the Manufacturing Institute's website and see it for yourself. But this is, again, trying to just capture what's going on, what is the reality, what do you need to be paying attention to, and some of the strategies that are being recommended for how to address it. Because there's some really good work going on. There's a lot of innovation happening. Where does that make sense for your company or your university? Where does your institution want to play in this space to help solve the challenge? There's another study I didn't put up here, but there's from the energy sector. So there's a lot of work on manufacturing. In the energy sector, very similar trends. This is a report put out by Manpower for the utilities. So these are our traditional utilities, American Electric Power, Dominion, those types of companies. Same thing. Massive challenges with an aging workforce where you've got some plants where you can have 50 to 70% of their workforce eligible to retire in the next 5 years. We don't have people in the pipeline. So if we want our lights on, we want our air conditioning running, and that's just what we have today. That's not even thinking about new technology. So actually, let me go back here. On the bottom there, if you can see that some of the strategies that groups like Manufacturing Institute and Accenture are really promoting, digital education, digital technologies. How do we ramp up, get more people going into the field? Once we get them in, how do we accelerate getting them through the process? So in particular, knowing that just looking at students coming through K through 12, that's one part of our talent pool. We haven't had as many children, honestly. So as a society, that's one pool, and we have a lot of work to do in that. We also have to look at how do we help our transitioning adults? How do we help them skill up, get through that training faster? And there's a lot of work going on how we can really effectively use online training where possible, often complemented with hands-on skills training as well. Upskilling your current employees, really taking a deep dive into, if I can't go find the talent I need, can I build the talent I need within those who are already in my company? And then having a very strategic plan around knowing what talent you need and when, and I'm going to talk a little more about that. Certification programs, a lot of work going on around that. How do we have standard certifications that are recognized? Groups like the Manufacturing Institute, Center for Energy Workforce Development are doing a tremendous amount of work in that. But if it's not adopted at the local level, if a local company, I work with energy companies in my community that are part of a national umbrella. Their national umbrella is a member of the organization that's coming up with all these great career pathway tools and certifications, but at the local level, their local hiring manager isn't connected. It means nothing to him, which means it means nothing to our faculty and it means nothing to our career counselors. So there's, again, this design process where we have to filter the good work that's going on, get it down, get it applied at the community level. Apprenticeships, I'm going to talk a little more about that, what we're learning from countries like Germany and how that, some exciting new initiatives on the horizon, and then expanding the talent pool. Kim mentioned Ohio TechNet. I just had the deep pleasure of helping to coordinate 11 colleges, including our own, to apply for a Department of Labor grant. It is pending, so keep your fingers crossed with us. It's a $20 million grant that would come to Ohio, part of a national investment in community colleges in particular to meet that middle skill occupational need. The balance we had there was, looking at what are the immediate jobs companies have today, because if we get these funds, we're going to be held to numbers around placement, while also looking to the future. How do we make sure that we're not designing programs for the past? We have to meet companies' needs today while designing for the future. But a lot of the innovations that we've heard from companies are needed, are built into this. This is the 4th round of funding. So I did put up a website there, openforus.org. This is a site funded by the Bill and Melinda Gates Foundation, where they're trying to capture a lot of open source innovation, a lot of curriculum models, anything that this particular program has funded, in theory is free for any of us to use. So again, at the local level, if you're not tapped into any of these partnerships, there's some good resources coming out of that project. The Speed to Market Accelerator, Dave mentioned in my introduction, is one of those national initiatives that's also really looking at how do we match our economic development investing with our talent and workforce investing, so that as a nation we can get ahead of this workforce challenge. It's really, having been in this arena for 25 some years, I love this project, and simply to describe it, the federal government, when they have funded groups like NORTEC is a regional economic development organization focused on helping companies commercialize technology using cluster development. This particular project is focused on advanced energy and flex electronics. And so what they did is they took a set of money and they said, okay, we're going to give you this Economic Development Administration grant. And concurrently, our college received a grant from the Department of Labor, Employment and Training Administration, but we have an integrated work plan. So we have a shared fate. Because when you think about it, when we invest our economic development dollars, those are our dollars as taxpayers, we're saying, look, we're going to make a bet on this industry and this sector. We as taxpayers believe that you're going to help create good jobs. What often happens is those jobs are high-tech jobs, engineers, those. Companies often then go out, try to find that talent, can't find it, go back to Congress and say, I need to recruit internationally for those jobs. Congress gets unhappy when we do that. They get unhappy when they invest in programs to create jobs, and then those jobs have to be filled with people other than their constituents. So the bottom line here is, if you look at this lens from those who make the decisions on where we place our tax dollars, is when we invest in economic development, how can I go home to my constituents and meet people who've benefited by getting those jobs? These are examples of some of the companies that are in that. And what I have really loved about this project, Quasar is a local company in the advanced energy arena that has a pretty cool technology, turning basically cow manure and other bio-waste into fuel. We have companies like Lumitex that is really helping to drive technological advance in flex electronics, using that technology both in biomedical applications. The backlighting in a lot of your computers is their technology. So it's just been really fun to work with them. Not large companies. Quasar went from about 30 employees, they're up to 90. So they are in a rapid growth phase. So our role and what we're really learning from this that has been particularly meaningful for us is these are a lot of small to medium companies. There are a few large companies that are certainly in this space. But NORTEC in particular is working with companies that are true startups to those small and medium. Companies that don't have a full HR department who can do active talent planning and forecasting and get out there and partner with companies. So what we're learning to do with this project is really serve as that role, making sure companies have a talent plan. So while they're thinking about technology commercialization and how am I going to go raise the money and how am I going to find that chief engineer, they're also thinking about 2 years down the road or 3 years down the road when they've gotten their investment from venture capitalists and now they need to go hire 10 or 20 or 15, 30 technicians. Where are those people going to be? Because guess what? They are competing against GE, American Electric Power, First Energy, Dominion, Alcoa, all these other companies that people know much better than Quasar or Lumitex. So part of what we're doing in here is facilitating a regional consortium. And I share this, again, not so much to brag about what we're doing, but it's a model. It's an example of the kind of innovation that's happening. Imperfect. We talk about it in our shop as this is our R&D division. This is where we're prototyping new ways to be of service to the community, to be of service to companies, and really figure out what is the magic elixir. We know in our community 60% of the job growth comes from small and medium companies. We've got to figure this piece out. We have got to figure out how to help those companies have a robust and thoughtful talent plan where they've thought those things through. We've got to help them communicate that information out into the network. So that's what this is about. We are facilitating this talent consortium where we bring universities and community colleges and workforce investment boards together simply to share what we're learning. We share real-time job postings. These are the types of jobs and internships coming out of these companies. These are other companies in our community who are posting similar positions. And we're trying the best we can to track how we're doing as a region and responding. This is just a short list. This could be longer, but this is to give you a sense, again, from our lens, all of the different things that are happening nationally at a state level, at a regional level, where more of that type of innovation, the type of innovation I just shared with you from the Speed to Market Accelerator, is happening through many of these other initiatives. Congress also funded the Make It in America initiative. We have one here in Northeast Ohio focused on advanced materials, where again, it's that economic development investment tied to workforce development. The Investing in Manufacturing Communities Partnership, I think there were 12 or 13 communities designated. Cincinnati, Ohio is one of them, looking again at economic development, workforce and talent. All of the NMI networks have, I think, a workforce development component. So again, we're excited to learn how is that information going to flow to us. I know from America Makes, we've been in a partnership to apply for 2 different research projects that had an education component. Those unfortunately did not get funded, but we know what we proposed on the education side, so we're eager to learn what those projects that did get funded, what they proposed, and where that information is going to go, and what do we learn, and how do we get that out to the community. A lot of folks are paying attention to apprenticeship these days. A lot of people are actually making trips to Germany. I'm willing to go if anyone wants to fund one. But Germany is being seen as a leader. They've really never given up on vocational education and training, and in fact, they're being recognized because they've taken what is basically an apprenticeship model and driven it to the high school level. So they are valuing the vocational and technical training that is just as important as sending our kids to college for the traditional 4-year degree, engineers, scientists, social service people. And so they have now, I think the number I read, 60% of students in high school in Germany are going through some level of apprenticeship program. 330 different types of apprenticeship. So here in our country, when we think apprenticeship, companies often think union, which in some areas is considered a dirty word. They think construction, they might think manufacturing, but they don't think about hairdressing. They don't think about IT. So what you see in Germany is a model where they recognize that apprenticeship is really, at the simplest level, how do you combine classroom training with on-the-job training? So you're building a direct relationship. There's a level of commitment that an employer has made. So I know that the training I'm going into is leading to a real job. Or ideally, I'm already hired. But there's a recognition that I'm not quite at the place the company needs me. So there's this shared investment in, we're going to hire you for cultural fit and for potential. But we're going to make that shared investment in you as an individual with that, while you know that you have that job set, assuming that you do what you need to do in terms of performance. Think of the difference of a student coming to our campus who's going, well, what's out there? What do I want to do? What does it mean to go into machining? What does it mean to become a software developer? And what happens when I graduate? So they're making this long bet, right? They're hoping if they do these 3 steps, there will be something for them at the end. So the basic idea of an apprenticeship is you put that something up front, and then you let people go through the training, and you do that through partnerships. In the U.S., there is a big emphasis on apprenticeship. So if this is at all interesting to you, if you are in a company that has any talent challenges, or you're in a field where you know that's a challenge, pay attention. This is going to be a big new push of the Obama administration. There's already $100 million pledged for this fall, and we've heard that there's a push for another $500,000 or so. Again, that's not huge amounts of money, but it's enough to really push the needle to adopt some of those things that we know work. There's also some good things already happening around the country. South Carolina, interestingly, is recognized as being ahead of the game on this. If you go to Apprenticeship Carolina, you Google that, some really interesting stuff will come up about what they're doing. Again, they've got a very robust system where they're getting focused predominantly, well, they started it out focused on young people in high school and really trying to, again, get them connected to jobs starting at age 16 and into the workplace using the apprenticeship model. But they've found that it's also working for out-of-work adults. And then my final thing is to share that after 11 years of effort, Congress has just recently renewed and updated the what used to be called the Workforce Innovation Act. It is now the Workforce Innovation and Opportunity Act. And why this matters to you, it was 11 years in the making. It was very overdue. So again, when you look at the infrastructure that affects how we train people for the jobs that matter to industry, this is sort of that enabling legislation that had really become sort of a challenge because it was getting clunky and it was kind of getting in the way. Congress has updated it. The president, I believe, signed it yesterday. So this is truly brand new. There's some great innovations. I haven't had a chance to even read the whole bill yet or read all the summaries, but this is one you want to pay attention to. Congress has actually done a good job, listened to those who study these things, and they've really built in a much more robust way for employers to be directly involved, to have incentives for training, to be reimbursed for training. So we're excited about this, and we'll be keeping you posted. Thank you.
Great, thank you. Okay, I've noticed that some of those apprenticeship programs in the South sometimes are coming with the companies that have moved in there, and BMW being one, I think, coming from Germany and kind of bringing their apprenticeship program here and getting people, you know, involved in it seems to be a good fit. We've got a good time for discussion and questions. I've got a list of questions here, but I really like to hear from the folks there. We have a microphone here for people who have some questions to ask. We'd sure like to hear from you.
Terry, I particularly resonated with your description of the apprenticeship program. As some folks around here have already heard, I started my career with Rolls-Royce over 42 years ago as an undergraduate apprentice. It was a 5-year indentured apprentice where my father signed over my care to Rolls-Royce, literally. Very old-fashioned, that's the indentured part of the apprenticeship program. But the first year of that apprenticeship, I was in what Rolls-Royce called the tech school, and you had every kind of machine tool out there, and you spent 6 weeks on every section, and I was working alongside craft engineers who were going to be tool makers and were going to be turning chips or making chips in the manufacturing plant. I prided myself in able to beat them on all the tests that we had. But then I moved on and I became an engineer. Rolls-Royce got their hooks into me. I did actually leave Rolls-Royce for 2 years and went to work for Boeing in Seattle, which is how I came to the States, but I'm now back with Rolls-Royce. The message that I want to bring is that was very much industry-led. It's the companies that undertook the responsibility to train their employees, and they had tech schools. And the Allison Engine Company, prior to that, when they were owned by General Motors, they had the GMI, General Motors Institute, where they did the same sorts of thing. Are there any outreach programs? I mean, you're talking about it from a community college perspective, and in fact, I went to the equivalent of a community college before I went to university and learned how to use machine tools at college as well as the apprenticeship program. Are you able to influence industry? Because what you're talking about is a college-based program, I think.
No, it's exactly the right question. All of this has to be industry-led, and there is a big push now. Some of the language you'll hear is industry sector partnerships, employer engagement, employer-led, but that is all the research shows, and you just know it from intuition. When employers are leading, then we know we can plan based on what those real-time needs are. The level of complexity is that you often need that backbone organization to help facilitate and guide those types of collaborations. So whether that's at the local level, the state level, or the national level, somebody, whether it's a company or a college or a workforce board, has to sort of be that facilitating agency. But where it does work best, and my work with the Ohio Energy Workforce Consortium is an example. This is Ohio Utilities, American Electric Power, Dayton Power and Light, Duke Energy, are certainly in that realm of an aging workforce. Their HR folks are nervous about it, but anyone who lives in Ohio knows the workforce overall has constricted. So what consumers have heard is, well, there's no jobs. First Energy just closed some plants. Why would I send my child into the energy field? If I'm a career counselor, why would I advise someone to go into energy? So, we have a line worker program that's not running. No one's hiring today, but it takes 2 years to become a line worker. So what's going to, so if companies wait till it's time to post, it's going to be too late. We have to figure out right now, when is your need going to hit? If your need's not going to hit for 6 years, what are you doing at the middle school level today to reach that target audience? And how are you going to stay with those people through high school? Those are the types of things that industry does have to do. And I think there's some, that's what I was trying to say, I think there's some great work nationally, how you keep it going at the local level as people retire. You get a champion in one company, they leave. So you got to have that CEO engagement who says, this is important to our bottom line. We're going to have someone assigned to this work regardless.
Good. Anybody else on the panel want to weigh in on that one? No? Okay. Great. Okay, other questions from the audience? The floor is open. If not, I'm going to knock out a few of the ones that I've been thinking about. So, Tim, we talk about the whole manufacturing process, and it seems to me, and from our discussion last night as well, that the process is enlarging. And at the same time, we talked about these companies who are, some small ones are getting new technology and moving ahead with it quickly. And I'm thinking particularly of, RP plus M and Togus,
Sure.
and how they took advantage of that. So could you talk a little bit about whether it's the compression or integration of these technologies and sort of the impact that it's having on the supply chain, and how the supply chain is going to kind of evolve and
Sure.
change?
So an interesting backdrop would be to use the agility, flexibility requirement. If you're in the industry today and you're a company producing something, it's probably better to know that you can identify the requirements and the dynamic changes in those requirements rather than not. So if you are dependent, or if you're part of a very serialized linear supply chain, there's a lot of steps that take before you can get to B through C or to C through B. And so what we're seeing is those folks who understand flexibility will quote unquote tool up their shops with folks who understand the 70 to 80% of what's going on. And then they provide themselves the 20% latitude to be flexible. What does that mean? That means we don't wait for 100% of the data to come in before we make a decision. That means we don't make 100% of all of the technology in-house purpose specific. That means you make technologies that have flexibility, modularization, stuff like that, such that you can do and provide for today, but then be able to respond tomorrow. What that does to your supply chain is condense it. Because I think what you're going to find out is you're going to have an integrated supply chain, but you're going to have integrated members who are integrated themselves. So where I might be a person who's just drilling a hole today and it goes to somewhere else to fill, maybe I am a drill and a fill. Maybe I'm automated drill and fill. All this kind of stuff happens. And when you get a shorter supply chain, the areas of variability and the areas of increased liability decrease. And that's a lot of things. I think we've talked quite a bit today about some technologies and workforce, but some of the biggest, especially with the institutes in mind, when you think supply chain, IP and liability are huge. Who's going to buy into this if I'm going to do more of the operations? But if you do more of the operations, you actually have control more of those operations. And with the digital enterprise, that data gets shared to a master file and everybody knows. And so I see the supply chain decreasing with the increased use of technologies. Small and medium manufacturers have the best opportunity to gain in that arena because they're quick.
Okay, good. Dan, you want to comment on that from the digital thread perspective?
Sure. One of the things that I think will have the biggest impact in manufacturing in the U.S. is the small and medium enterprises. the integration of the advanced manufacturing enterprise, the digital thread, linking all of the suppliers together will have a tremendous impact. It will eventually change the way manufacturing is done across the U.S. and across the world. I think the supply chains will also, in another respect, grow internationally. Most of our companies are global companies. I think we'll see much more integration across all boundaries to where everything becomes more virtual. Those will be some big impacts. Yeah, the small, medium enterprises in the supply chain is going to be one of the biggest changes in the whole manufacturing chain.
I'll just add one thing to that. With that comes accelerated innovation cycles. The other thing that's happening globally, as we all know, is the way we do IP is changing. The world is shifting beneath our feet, and the U.S. patent and trademark protection is not going to be able to be what it has been for the last 100 years. And so the necessity of accelerated innovation cycles, because you can't protect it for a long time anymore. So I think that's a really important component, and it makes the digital thread and the other things we're trying to do to integrate it, do more of it virtually before you launch it, all the more critical to staying competitive and on top of that.
Good. Larry?
I guess I would take maybe a slightly different view for the second and third tier suppliers out there. Machining is not going to go away. Castings are not going to go away. Bending metal is not going to go away. So, there are going to be some changes in some products that can take advantage of these tools and capabilities in additive manufacturing or adaptive manufacturing. But it makes absolutely no sense at all to think about doing a powder metal process on making quarter-inch screws. It's totally illogical. It'll never pan out economically to ever do that. So there's going to be a need for those basic fundamentals are going to continue and will happen. I think there's going to be an opportunity for some of those companies to pick up some of these newer capabilities and add some product levels. Some prime contractors are going to bring some of that work in-house at that level and do some more in-house. But a lot of the key pieces are still going to be there. For example, you saw this morning on the GE pitch, they still had to go, after they did the powder metal work, they still had to go machine and clean up the hardware and make it usable. So machining is still going to be required in many, many applications. So I would say let's not paint a gloom and doom picture for the supply base. I think it's an opportunity being developed for the supply base. I think there's going to be more products that we could bring to market. And as I mentioned before, because we're now able to make highly tailored engineered products, the market is going to be totally different. And so we're going to be bringing things to the marketplace that currently are not available in the marketplace because of the current limitations of the manufacturing capability. By changing those manufacturing capabilities, by being able to do integrated powder metal processes where you've got aluminum, titanium, copper, et cetera, all being put into a bath at the same time and making a fully engineered integrated part, it's going to be different. And it's going to create some great opportunities, I think, for folks along those lines.
Okay, thanks.
And we're doing, I know our faculty are looking a lot at digital design and really, again, that how do we help companies both think about the different approach to design, but also our teaching methodologies that embrace the changes in how you help with digital fabrication. And I was interested to hear about the new equipment that's looking at both additive and subtractive, because that's what our dean keeps saying, is it's, companies are still using both processes. There's a lot of work in both. And then we're certainly looking in sensor and just that whole arena of commercialization. How do you help companies take this technology? And in particular, right now we're looking at the sort of the marriage of the fab labs and this technology on digital design, combined with the rapid growth of sensor technology and how that's predicted to continue to have a huge impact in manufacturing, and how we leverage both of those sets of expertise in the commercialization process.
Good.
I want to add something to that thread of discussion. I actually believe that with additive processing, additive manufacturing, 3D printing, whatever we call it, the individual becomes even more important, because we have these tools, but you are creator, you are source. You will create something that's never been done before, combine it in ways that's never been thought of, and it doesn't matter how old you are. It doesn't matter if you have no money, it matters not. And I'm incredibly excited about that aspect of manufacturing now being accessible to more people in more places than ever before in the history of humanity. This is critical. And I think what we're trying to do from maybe at the top level with the large legacy companies in some respects is help them adapt to that. This is incredibly disruptive to humanity, but it's great. And the way we educate our children and re-educate our workers to engage like that instead of waiting around for something to come out, that's a mind shift that has to occur. I just think it needed to be said.
Yeah, I agree. As a specific example, there's a group of young students at University of California, San Diego, about 8 undergraduate students as sophomores and juniors that built a 200-pound thrust additive manufactured rocket engine from scratch, took it out the desert and fired it. And they did it all for like $8,000. I mean, mind-boggling what you can do with this capability if you turn those folks loose. I agree, totally. And specific examples like that need to be held up to say, here's how this can work.
I've been a judge for the FIRST Robotics program. We're working with high school kids for about 14 years now. In the last 2 years, Additive has been added to part of the robot competition, and there's a separate contest for the best use of additive manufacturing as part of the robot. And so the access now that these schools have that are starting to get into that is really pretty amazing. And some of the technology or the parts that they produced have been really incredible. So it's been really good to see. From the whole idea of this maker concept, Tim, what do you see with that and how that sort of?
Well, it goes back to what Kimberly has talked about and Terry's talked about. Well, actually, all of us have talked about to some extent. It's the outreach. It's the first time that the wave of outreach and awareness gets to the masses. And when you take the word manufacturing out, all of a sudden people seem to be interested. You talk about it being a maker movement. You talk about, and that's fine. Who cares? I mean, call it cats and mice if you want. As long as you're out there building cool things and it works and you learn it, go do it. And the whole maker environment has brought building things back into the coolness factor. If you ever go to these maker fairs, if you have a chance to do it, I encourage you to, because the environment is something between a Renaissance festival and a carnival, to how I made it and the Discovery Channel, the guy is always out there and, just blowing things up and doing. That kind of stuff gets people excited. And we all know from an engineering standpoint, especially from a manufacturing engineering standpoint, you really don't know until you sometimes get in there and build it. Now, I fully support the simulation, especially for qual and cert. Don't mix that message. But there's something about building it, breaking it, and learning from it. And that's what the maker community, I think, is really starting to give back to our entire industry.
That's encouraging and optimistic, and this whole idea of sort of the grassroots and the coolness aspect is, I think, one of the things that Additive does bring to advanced manufacturing, a total different appreciation for manufacturing itself. And those kids don't even know they're manufacturing. I mean, don't call it that it maybe would turn them off, but they're able to do it, and that to me, I think, is one of the most promising parts of it. I think we're probably, you guys have other questions or comments, but I think we're getting about ready to wrap this up, and I know there's a lunch coming up at noon, and I see we've lost a few folks already, so, but thanks everybody for your attendance, appreciate it, and thanks especially for this panel. You guys were amazing, and I really appreciate your work.